Why do solar flares release X-rays and gamma rays? Imagine the sun as a giant ball of fiery energy constantly bubbling and shifting. When it suddenly releases a burst of intense light and radiation, we call that a solar flare. But have you ever wondered why these solar explosions send out X-rays and gamma rays? Well, it all comes down to the sun's magnetic fields and how they behave during these explosive events. Solar flares happen when the magnetic fields in the sun's atmosphere become tangled and then suddenly snap or rearrange. This process releases a huge amount of energy stored in the magnetic fields. When this energy is released, it accelerates charged particles like electrons and protons to incredibly high speeds, close to the speed of light. These particles then interact with the surrounding plasma, which is a hot, ionized gas made up of charged particles. The first part of the process produces X-rays. When the high-energy electrons collide with the particles in the plasma, they slow down and produce X-rays through a process called bremsstrahlung, or breaking radiation. The more energetic the electrons, the more intense the X-ray emission. These X-rays come from the hottest regions of the flare where the particle acceleration is most vigorous. Gamma rays are produced through a different mechanism. When the accelerated protons and heavier ions hit nuclei like carbon, nitrogen, or oxygen in the solar atmosphere, they cause nuclear reactions called spallation. These reactions releases gamma-ray photons as a byproduct. Sometimes, energetic protons from the flare can also interact with the plasma itself, creating even higher energy gamma rays through hadronuclear interactions. The temperatures during a solar flare can reach between 10 and 15 million Kelvin, which is extremely hot. This heat helps accelerate particles to relativistic speeds, meaning they move close to the speed of light. This combination of magnetic energy releases, particle acceleration, and nuclear reactions creates the broad spectrum of radiation we see, from radio waves to gamma rays. Understanding why solar flares produce X-rays and gamma rays is important because these high-energy emissions can impact Earth. They can disturb our planet's ionosphere, interfere with radio signals, and even affect satellites and power grids. That's why scientists keep a close eye on solar activity, using space-based observatories to monitor these energetic bursts and help protect our technology and communication systems. So, next time you hear about a solar flare, remember it's not just a bright flash in the sky. It's a complex event driven by magnetic forces that accelerate particles to extreme energies, producing the X-rays and gamma rays that reach across space and sometimes even impact our world.